Okay, so for this first problem, we're going to start off with a tank that's got 100 gallons of pure water. We're going to have a solution that's going to contain 5 pounds of salt per gallon entering the tank at a rate of 2 gallons per minute. A drain is open so that the volume of the tank stays constant. And we want to look at how much salt will be in the tank after an hour and how long it will reach 50 pounds, and then what's the eventual content. So when we do these problems, the most important thing to do is take a look at the information given to you when it comes to concentration going in and flow rate going in. So the concentration going in is going to be 5 pounds per gallon. And we'll look at that as blue. The flow rate going in, that's going to be the 2 gallons per minute. And then the concentration going out, that's the hardest part of this because that's going to be varying with time. It's going to be changing as we go. For this particular problem, the flow rate going out is the same as the flow rate going in because, again, we're keeping the volume of it constant. So when we write our differential equation, it's very helpful to put the units into the equation. So we've got a dx dt is equal to the concentration going in, which is, again, 5 pounds per 1 gallon. And that's now multiplied by the flow rate going in, which is 2 gallons per minute. That's now minus the concentration going out, which we'll save for a minute, and then the flow rate going out, which we know is still going to be 2 gallons. Said gallons per minute. Now to fill the concentration, we're going to have it changing over time. So we usually use x of t to represent the number of pounds at any given time in our tank. And then the volume of our tank is going to be 100 gallons. And again, we have a little multiplication symbol there. So our equation is dx dt equals 5 pounds per gallon times 2 gallons per minute minus x of t pounds dissolved in 100 gallons times 2 gallons per minute. And our initial condition is x of 0 is equal to 0 pounds because they tell us in the problem that we have pure water at the start. So pure water means there is 0 salt content in the tank. So the next thing you'll notice here is our units are always balanced because remember, x is the number of pounds, t is time, so this is going to be pounds per time. And you'll notice here that the gallons cancel in the first term and the gallons cancel in the second term, so you have pounds per minute in both terms. And this is very important because in all these calculations we have to always add and subtract like terms. So now let's write this over again. Dx dt is the same thing as x prime, and that is equal to 10 minus 2 over 100 times x. And of course that simplifies down to just x prime is equal to 10 minus 1 over 50 times x. And this equation, if you look at it, is both linear and separable. The easiest way to handle it is to treat it as a linear equation. So our integrating factor is going to be found from putting it into standard form and integrating. So our first step, of course, is to add the 1 over 50x to both sides. So when we do that, we're going to have x prime plus 1 over 50 times x is equal to the number 10. Okay, so now we need to find our integrating factor, which is going to be mu of t is equal to e to the integral of 1 over 50 with respect to t, which is just simply e to the 1 over 50 times t. Okay, now we need to multiply that integrating factor to our differential equation. So we're going to have our e to the 1 over 50 times t times our x prime plus 1 over 50 times x on this side, and of course we have 10 times that same e to the 1 over 50 times t. We now need to go through and distribute. So we have an e to to the 1 over 50 times t times x prime plus our e to the 1 over 50 t times the 1 over 50 times the x, and that's still equal to 10 e to the negative 1 over 50t. We now recognize the left-hand side as the derivative of the product e to the 1 over 50t times an x that was differentiated to make this 10 times e to the, and that's not negative, that is positive. My apologies, I don't know where that came from. All right, and that's e to the 1 over 50t. And in our next video, we will go in and we will integrate both sides of this with respect to t.